Hello, my name is Ameen Aslam, and I'm the Applications Manager at OmniTier Inc. And today I'm here to talk about our MemStac solution, which is an in-memory processing solution and a drop-in replacement for Memcached. So why in-memory processing? Let me first start by saying that there is a growing market and need for in-memory processing. With in-memory processing, a business can service more users while maintaining consistent application performance. On the flip side, this loss of caching leads to an increase in average page load times. This means less concurrent users are getting consistent performance. As a result, as traffic increases with more users, more strain is put on the backend database, which inevitably results in lower quality of service. So what solutions are out there in the market today? Today's market is dominated by DRAM-only solutions. DRAM solutions, such as Memcached, provide the application performance needed to solve the previous problems shown. However, there are limitations to today's solutions. The performance comes at a cost, and DRAM is significantly more expensive than other media, such as SSDs. Servers have a limited number of DIMM slots, and there is an overall capacity limitation with the amount of DRAM that can be deployed in a single server. And finally, DRAM is very power hungry. So where does OmniTier's MemStac fit in? MemStac provides an integrated solution that can deliver DRAM equivalent performance, and in some cases, even higher application performance at a much lower TCO. MemStac's nodes are denser than a typical DRAM-only node, which allows scalability at a lower cost. And these cost savings are coming not just from the memory, but from potentially fewer cache servers that need to be deployed. In comparison to a DRAM-only solution, MemStac is also a lower power alternative. So OmniTier's MemStac gives a significant boost to application performance while reducing the overall strain on backend databases and keeping a lower TCO. Now, I'm going to talk about two real proof points that showcase MemStac's value proposition. The first proof point is a direct comparison of MemStac versus Memcached. For this demo, we have deployed 15 servers on the IBM cloud. Our applications are running an e-commerce store, which was generated using WordPress, and we've populated the store with hundreds of thousands of products that users can browse. On the front end, we have thousands of users logging into our system, going through a load balancer to distribute the load among our application servers. The application servers are then requesting the necessary data from the cache servers. For this side-by-side demo, half of the setup is powered by a DRAM-only solution, and the other half is powered by MemStac. And for this demo, 100% of the backend database information is resident in the cache. For this apple-to-apples comparison between a DRAM-only solution and our solution, we have actually crippled MemStac to run at a lower capacity. The following is the results from our Kibana dashboard that is monitoring the application performance as well as the backend cache performance. The top two graphs are application level, showing the number of page requests per second and the associated latency. The bottom two graphs show the corresponding cache performance. For a typical e-commerce web page, a single page request can result in hundreds of backend queries. And as you can see, we are seeing hundreds of thousands of cache requests for 1,000 page requests per second. The corresponding latency is only a few hundred microseconds per cache request. From this demo, even after crippling MemStac's capacity, MemStac can provide DRAM equivalent performance while keeping a reduced TCO. Now, let's explore the capacity aspect. In the previous demo, 100% of all data is coming out of the cache. However, a more typical use case for a DRAM-only solution with capacity limitations is having less than 100% hit rate. So, similar to before, we have users logging into our e-commerce store, but this time, not all data can be held by the DRAM-only solution. And half the time, the data will have to be fetched from the backend database. This results in a lower application performance. On the other end, we have MemStac, which for the same cost is able to hold more user information and service more concurrent users at once. So now we will show the viewpoint of a user being serviced by memcached and one by MemStac. So the user on the left is a memcached user, and the user on the right is a MemStac user. As you can see, the page load times are much faster for the MemStac side. MemStac is providing higher application performance compared to a DRAM-only solution. Without increasing the cost, MemStac delivers higher application performance compared to the DRAM-only solution. Now, why is this important? Well, companies such as Amazon have found that a 100 millisecond increase in load times would reduce sales by 1%. To summarize, MemStac provides DRAM equivalent performance and in some real-world use cases, higher application performance compared to DRAM-only solutions. MemStac has an overall lower TCO and given more memory per node is a more scalable version than DRAM-only solutions. This allows for a saving on both memory and cache server costs. MemStac is a solution for an ever-growing in-memory processing market and solves the problems that face current DRAM-only solutions. Thank you.